Good morning, this is Mr. Morales, and I'm going to go over the review for the Common Assessment for the second 9 weeks. For the sake of argument, since it's double-sided and they both look very similar, I'm going to call this side A, and that's the side with the short answers, where you have to do all the work for the most part. I'm going to go ahead and explain the solutions for all these questions. So let's go ahead and just start. So, for number 1, we're asked to find the domain and the range. We're going to move away from the notation with the infinities and whatnot, and greater than equal and less than equal signs. And what we're going to do is go ahead and just explain with words. So what we have here is domain and range. We have a continuous function that ends and begins at certain defined points. So the domain in this case, which measures the width, goes as far left as 0 to 16, including those numbers. So we say the domain is all real numbers that are greater than or equal to 0 and less than or equal to 16. So everything from 0 to 16, including those two numbers at the end, because our points are solid. And the range behaves much the same way. The range is going to be all the real numbers that are greater than or equal to 0, which is the lowest part of the graph when it reaches the bottom down here, equal to 0, and less than or equal to positive 1, 2, 3, 4, 5 on this graph. A lot of students always want to go from highest to lowest because they're reading the graph from left to right, which I understand. However, one of the biggest misconceptions is doing that. So what you need to do is always go from least to greatest on your graph, and least to greatest, especially when you're reading the range, no matter what direction your graph goes. So those are those first two solutions in words. Number 2, I went ahead and I used a calculator and entered in all my points, like you should have been shown by your teacher in class already to get all the information. And when I did so, here's what I got. I graphed my points, and here's what my graph should have looked like. I went ahead and did the regression line, and I got y equals 0.96, because I rounded to 2 decimal places, plus, it says negative, so it's going to be just a minus 0.008. I had to go 3 decimal places there to get the number to fit. So here's my equation line. Then to get the correlation, I went back to my data set over here, and in 1.1, let's see, I think I have it already done. And, oops, hold on. Give me 1 second, I am a bit in a rush because, as you know, my videos tend to cut out on me at the worst possible time. So here we go. The correlation is 0.982511, and I went ahead and rounded that to 0.983. Our correlation in this case, 0.983. 0.983 is very close to positive 1, so that is what we consider a strong positive correlation. Question number 3. Here we just have the breakdown of a standard graph. They want to know the slope, the y-intercept, and the x-intercept. In other words, the 0. Remember, x-intercept also can be referred to as 0. So the slope, I actually use the intercepts, and you go up 5 squares, 2 to the right, so that's a positive 5 over 2. Your y-intercept can be written as a negative 5, or if they want coordinates, 0, negative 5. Your x-intercept right up here is at positive 2, or you can say 2, comma 0. So those are the first 3 answers for your short answer review.